Okay, I'm going to give you a little review on pedigrees first, and then I'm going to give you a review on all 4 different types of inheritance just using Punnett squares. And I'm actually going to do the same example just using the 4 different forms of inheritance. So let's start off with our pedigrees and just reviewing those. Now, the first thing you guys want to do on the pedigree, this is your first step, always the first step, is to determine what the inheritance pattern is. On the keystone, most of the time, guys, they put autosomal recessive, autosomal dominance, or sex-linked recessive. Those are the 3 ones that they usually like to use. Now, for autosomal recessive, I'm going to do that one first, all right? We're always going to have the same shapes here for our individuals. So we're going to have circles for the females. We're going to have squares for the males. And I'm giving you 2 of each because, whoops. There we go. I'm giving you 2 of each because one of them I'm going to fill in. The filled in one is affected by the trait. Now, when you guys see autosomal here, there's 2 different types of inheritance. There's going to be autosomal and there's going to be sex-linked. If we are doing autosomal, what this means is it's going to be on chromosomes number 1 through 22. What this means for us guys is we don't have to worry about using the X and the Y's like we did with sex-linked inheritance. If we are doing sex-linked, that's when we got to use the XY's in there. So, autosomal recessive. What this means is that when we're assigning genotypes, our affected one is going to be that homozygous recessive genotype. Okay? So we know if it's a filled-in female or a filled-in male, it's going to be little r, little r. All right? The other ones here, it's regular complete dominance, so they could be big R, or they could be big R, little r. And nothing changes between males and females. It's the same thing, we just get different shapes. Okay, so let's go. I'm going to make a quick pedigree for you here. I have a female, and her and a male. We're going to have some kids together. Let's say they have 3 kids. Say they have a female first, a male second, and then they have another male. It always goes from left to right. The left one is going to be the oldest, and the right one is going to be the youngest. And let's say the middle child is filled in. Then let's say this one here marries a girl. They have 2 kids. Female that's affected, and a male that is not. Okay, so in order to know what I'm talking about, they're going to put generation numbers on the side in Roman numerals. And then we'll tag each one of these with some numbers so that we know what individual we're talking about. Okay, so here's our first step, guys. We're going to determine what the genotypes are for number 1 and number 2 of generation 1. Let me repeat that. We are determining the genotypes of individuals number 2 and number 1, generation 1. So I'm talking about these 2 up here. So in order to determine that, we got to look at the kids. Now, we know that they cannot be little r, little r. If these were little r, either one of them, they'd be filled in. So let me try this. And I like to be wrong, guys, just because it helps to justify the right answer. So I'm going to say number 1 is big R, and I'm going to say number 2 is big R, little r. There you go. Okay? Now, if we look at their kids, they had 1, 2, 3 kids. If we look at this Punnett square here, there's no little r's in there. But number 2, we know, is little r. So they can't have any of those. So that cannot be correct. So let's try another one. if they're both heterozygous, now we get that little r in there, okay, which is that one. So that is what both of them are. They are both big R, little r. Now let's look at number 1 here. This is the correct Punnett square down here. Well, number 1, we have no other information. Number 1 didn't get married, didn't have any kids, so they could be big R, big R, big R, little r. We can't determine that. Now number 3, we can determine. Number 3 over here, he marries a girl and they have 2 kids, and the first one is affected. So once again, these both have to be heterozygous, number 3, and number 4, in order for them to have this affected kid, okay? And then number 2, once again, we couldn't determine. But again, this is an autosomal recessive pedigree. You guys can see that the affected ones are going to be homozygous recessive, okay? And that's when it says autosomal recessive. So let me do the next one. Next one's going to be autosomal dominance. So you guys will see the difference here between the last one we did and this one. Okay. We're still going to have the same 4. Whoops. Sorry, I meant to draw a circle. There we go. Okay. All right, once again, we got males, we got females. Circles are the females, squares are the males. Now, here's where the difference is. Autosomal dominant. The dominant ones are going to be the ones that are affected by the condition. So, the not filled in ones, these are going to be the homozygous recessive this time. And the ones that are filled in, these are going to be big R, or big R, little r. So it's completely the opposite of the last example. I'm going to use dwarfism for my pedigree here, for our trait. So we are going to have 2 filled in circles. What this means is if they are filled in, they have dwarfism. If they're not filled in, they don't have dwarfism. So these 2 have some kids. Okay. So we know this is generation number 2. We know that individual number 2 here is going to be little r. Given that, we know that these 2 up here, in order to have a homozygous recessive child, both of these ones, just like the last example, have to be heterozygous. Okay? Let's say number 4 marries this person. And we know this person would be homozygous recessive. All right. Now, we cannot for sure determine the genotype of number 4, but we can use probability and get it pretty close. So we know number 4 could be big R or big R, little r, because it's filled in. So I'm going to do 2 Punnett squares here. I'm going to do the big R1, and I'll also do the big R, little r1. And the dad in both examples is little r. That is number 5 of generation number 2. Okay, so if we look at, I'm just going to call this one Punnett square number 1, and this one will be Punnett square number 2. If we look at both of these Punnett squares, number 1 has a 100% chance of the children having dwarfism. Number 2, it's only these ones, Number 2 has a 50% chance of the children having dwarfism. Now, we cannot be for certain for this, but if you look here, we got 3 kids that all have dwarfism, all right? It could be by chance that it could just be, for Punnett square number 2 here, the ones on the left side, but more than likely, number 4 there is probably big R, just because all the kids have dwarfism and none of them are little r, okay? So this is autosomal dominance. As you can see, guys, it just flips. The affected ones now have the dominant genotype, the big R or the big R, okay? All right. Now let's do the last one. The last one is our sex-linked recessive. This is the one where we are going to have to put in our X and our Y's, okay? So a little bit different here. There we go. Okay, so we're going to have our females, we're going to have our males. Now we know since it says recessive, we know that the filled in ones are going to be that recessive genotype. But again, we've got to put the X's and the Y's in. So an affected male, X little r, Y. An affected female, X little r, because remember, the Y is not going to carry our X-linked traits. Now, if it's a female and it's a open circle, 2 genotypes it could be. It could be XR, X big R, or it could be X big R, X little r. Males can only be X big R and a Y. All right. Now, if we look here, the females have 2 different genotypes that save them from this condition, whatever this might be. The males only have 1. Let me go turn the lights back on. Give me 1 second, guys. Okay, so like I said, the males only have 1 genotype that saves them. They have the X big R, Y, where females have 2. So usually in a sex-linked recessive pedigree, we're going to see more males being affected than females, okay? All right, so there's that one. All right, so we did a 4-generation one here. 1, 2, 3, and 4. Now, we know we can go in and fill in all the males right now if we wanted to. We know this one is X big R, Y. We know this is X big R, Y. We know this one is X big R, Y. And this would be X little r, Y. X little r, Y. And X little r, Y. Okay. Label my individuals so we know who we're talking about here. Okay. So for this one, guys, let's determine number 1 right now. Number 1 could be big R or big R little r. Well, if we're looking here, look at the males. The male up here is giving his Y to each of these males. So this X big R is only going to the female. This tells us that this person right here has to be X big R, X little r, because these males right here and right here got that X little r. That's why they're affected, okay? Number 4 over here. All right, this one's a little bit tricky. This one, the male is X little ry, okay? The male over here is X big RY. So we know that this female has at least one X big R. Okay, we don't know if it has 2 or not. Let me go down to generation 3 because that might help us out a little bit. We know this is X big RY. Number 2, we know this one has to be X big R, X little r. All right? Because the son down here has the X little r, which he's going to get from his mom, from the female. Okay? And then you got the Y from the dad. This one here, we actually can't determine if it's X big R, or X big R, X little r. We can't determine if it's homozygous dominant or homozygous recessive, just because the 2 kids, it could work either way. Okay? So this is a sex-linked one. They're a little bit easier, I think, than the other 2, just because we know what all the males are. You might also see this, guys. Sometimes they'll, in sex-linked, they'll color the females like this if they're a carrier. So I wanted to show you that as well. And what this means, guys, is they don't have the trait, but they are a carrier for the trait. So you could see that brought in there. All right? Okay. So that is pedigrees. Hopefully that helped you guys out a little bit. So I'm going to give you guys 4 different things here. So we're going to do, let's go blue is dominant to, I don't know, white. All right. If it is complete dominance, so I'm only going to talk about the heterozygous ones because we know the rest of them by now. We know homozygous dominant is always going to be the blue color. Homozygous recessive is always going to be the white color. All right. Now, I'm only showing you the heterozygous ones here. If it is complete dominance, it's going to be a blue color. If it's incomplete dominance, it's going to be a blend of the 2, so it's going to be like a light blue. It's codominance. It's going to be, let's say, white with blue stripes. All right, I'm just making up. It could be blue with white stripes. It could be blue with white spots, whatever. Okay, so that's the difference between all of those. Now, let me do some genotype work with you on this same example. So if it's going to be, I'm just going to do complete. Big R, little r would be blue. Let me list the other ones too, just so we have them all. Big R would be blue. Little r would be white. And this is for complete only. Incomplete. Big R is blue. Big R, little r is light blue. And little r is white. Codominance. So we're going to have 2 different genotypes here. I'm just going to say big R is going to be blue. Big R, remember we use 2 different letters for this. Big RW is going to be white with blue stripes. And then lastly, WW is going to be white. The last one I want to do is our sex-linked. Now, I'm going to say, and you guys kind of got to watch for this, it could be sex-linked complete dominance, sex-linked codominance. Just watch for that. I'm going to do the codominance one. So if it's a female, if it's X big R, X big R, it's going to be blue. If it's X big R, X little r, it's going to be the white with blue stripes. And X little r, it's going to be our white color. Okay, we can also use W's in there if we wanted to. For the males, so it's going to be our XY for males. And we only have two different genotypes. We have X big RY, which should be blue. We have our X little r, or WY, which is going to be white. So we cannot have males white with blue stripes, all right? So when you're doing any kind of Punnett square problem, guys, your first thing is going to be to determine what is going on with the inheritance. Is it complete? Is it incomplete? Is it codominance, or is it sex-linked? Determine that first and then carry on with the rest of the problem, because you'll know all of this based on the type of inheritance, okay? So hopefully this helped, guys. Hopefully this gave you a little bit of a review on pedigrees, and I'll see you guys next time. Have a good day.